So I want to start with calculated columns because they're a bit more user-friendly, a bit more intuitive, especially for people coming from an Excel background. So simply put, calculated columns allow you to add new formula-based columns to the tables in your Power BI file. A couple important things to note. Number one, there's no A1 style references. You can't point to cell D16 or cell B5. Calculated columns refer to entire tables or columns. Next, calculated columns actually generate new values for each row in the table, and those values are actually visible within your tables in the data view of Power BI. And then third, calculated columns understand something called row context. What I mean by that is that they can see the information in each row in which they calculate, and so they're great for defining things like properties based on information in that row, but they're generally useless for things like aggregation, like sums or counts or averages. So important note here. As a rule of thumb, you're going to use calculated columns if you want to stamp static fixed values to each row in one of your tables. Or you can also use the tools in the query editor to do the same thing in many cases. What you don't want to do is use calculated columns for aggregation formulas or to try to calculate numerical values to use in the values area of a visualization. We'll be using measures for that instead. So pro tip, calculated columns are typically used for filtering data, giving you new fields that you can use to create those filters rather than creating or defining new numerical values. So let's walk through a couple quick examples. Here we've got two different tables, and in each case we've created a new calculated column. Now you'll note the DAX formula in the formula bar at the top, right above the table preview. And here in this top example, we've created a new calculated column that we've named parent, which equals yes if the total children field in that table is greater than 0 and no otherwise. And when you read through this formula in the top left, you'll notice that it looks very, very similar to Excel. So that same kind of user-friendly syntax. Now remember, since this calculated column understands row context, a new value is calculated in each row based on the associated value in the total children column. So what we're doing is cycling row by row by row, looking at the row context and returning the proper value based on the formula. So this is a valid use of calculated columns. Creates a new row property that we can now use to filter or segment any related data within the model. So we can grab that parent field, pull it into a visual, and break down our numerical metrics or values to compare data for parents versus non-parents. In this second example here, we're actually trying to use an aggregation function, in this case a simple sum of the order quantity field, to create a new column named total quantity. But here's the thing, since calculated columns don't understand filter context, and we'll get into that a bit more, the same grand total is returned in every single row of the table. So it doesn't matter which row you're in, whether you're calculating the value in row 1, 2, 3, or 4, in every single case, the sum of the order quantity field is the same sum, the same total. So this is not a valid use of calculated columns. We've essentially just taken that grand total and we've stamped it into the table in every single row. And in doing so, we've created this static column of numbers that can't be filtered, sliced, or subdivided any way. So for something like this, teaser alert, we're going to be using measures, the other important application of data analysis expressions. So let's quickly hop into our Power BI file and run through a quick demo for ourselves. Okay, so once you've opened up your AdventureWorks report, head to your data view and click on the sales table. Got my order quantities. And if you'll remember that earlier in the course, when we covered the query editor, we used that conditional column tool to create a new column called quantity type that was based on the order quantity here. So any rows where the order quantity was greater than 1, quantity type took a value of multiple items. Otherwise, it took a value of single item. So I'm going to quickly show you how we could have created the exact same calculated column here using DAX as opposed to using the tool within the query editor. So again, one of those common themes that we'll see time and time again, multiple approaches to solving the same problem in Power BI. So what I can do is right click, add a new column, And right up here in the formula bar is where I'm going to write some DAX. Don't worry about the syntax quite yet. We're going to dive into exactly how DAX formulas are written and then do a ton of demos with some of the most common functions. But for now, the focus is really just on when and why to use calculated columns instead of measures. So for the sake of example, we can name this quantity type equals, and now start typing our function. And in this case, we're going to use an if function. So if, and I'll start typing the name of the column. DAX uses something called IntelliSense, just like Excel formulas autocomplete. It provides a list of my options dynamically as I'm typing. In this case, I want AW sales order quantity. Just double click to lock it in. So if order quantity from my AW sales table is greater than 1, comma to my result if true, which is multiple items in quotes, comma again to my value if false, which is single item. Close the parenthesis, press enter, and that will lock in my new quantity type column here. So again, same exact logic that we used when we created this column in the query editor, except this time we've done it on our own using DAX. And if we scroll down, we see our single type items here, and then we've got some multiple type item categories where the order quantity is greater than 1. So it seems to check out. That is a valid use of a calculated column. Now, if we were to add another calculated column, new column, and this time name it something like total quantity, and give it an aggregation function like the sum, of AW sales order quantity, and enter that. Just like we showed before, we get that exact same duplicate total stamped on every single row, because in this case, the row context is meaningless, and the sum of that quantity column is always going to return that same grand total of 84,174. So again, let's delete it. This is not a valid use of calculated columns. What we want to use instead for something like that is a DAX measure, which we're going to talk about now.